Hey guys, this is Miss Mosier here. Today I want to talk about simplifying radicals. You've seen me mention this a couple times in the packets I've been doing. So I just wanted to do a short little mini lesson on how to simplify numbers that are underneath the square root. So keep in mind, another name for this symbol right here is not just square root symbol, it's also radical. Right, so the radical symbol is this right here. And why is it not just called the square root symbol? Well, it's because it could be a cubed root, it could be a fourth root. It's not just a square root. So this is the name for this symbol. It's called a radical. All right, so let's look at example number 1. I want to simplify the square root of 72. All right, when we do this, we want to think of numbers that are perfect squares that go into 72. And by a perfect square, I mean you can square root it and get a whole number. 72, well, the square root of 64 is 8. The square root of 81 is 9. 72 is in between that. I can't square root it and get a whole number. So are there any numbers that go into 72 that are perfect squares? So let's just make a list of factors. We have 1 and 72. We already talked how 72 is not a perfect square. 1 is, but that's not really going to help me simplify this. All right, 2 times 36. Oh, 36 is a perfect square. 6 times 6 is 36. So let's go ahead and rewrite that. That's a pretty big number. There's probably, well, considering that 72 is not a perfect square, that's going to be our biggest perfect square. So let's rewrite the square root of 72 as the square root of 36 times the square root of 2. That's totally legal in the math world. You can separate it like this, because if we multiply it back out, the square root of 36 times the square root of 2 is the square root of 72. Now we just take the square root of 36, that is 6, and we leave the square root of 2. And that is our simplified answer. The square root of 72 can be simplified to 6 times the square root of 2. All right, let's try another one. Example 2, the square root of 50. Let's start by listing factors of 50. 1 and 50. 50 is not a perfect square. If we think 7 squared is 49, 8 squared is 64, 50 is in the middle of that, it's not going to work. All right, 2 times 25. Ooh, 25 is a perfect square. 5 times 5 is 25. So we're going to rewrite this as the square root of 25 times the square root of 2, and the square root of 25 is 5. 5 times the square root of 2 is what the square root of 50 simplifies down to. Okay. All right, 20. 20 is not a perfect square. Let me think. 3 squared is 9, 4 squared is 16, 5 squared is 25. It's in between there. So let's write the factors. 1 and 20, 2 and 10. No, 10's not a perfect square. 3 squared is 9, 4 squared is 16. All right, 3 doesn't go into 20, 4 and 5. Oh, 4 is a perfect square. So we're going to rewrite the square root of 20 as the square root of 4 times the square root of 5. 5 is a prime number. I'm not going to be able to break that down anymore. The square root of 4 is 2. So this would simplify to 2 times the square root of 5. Okay, so again, this is just a short little mini lesson on how to simplify radicals so that your answer can be in simplest form.